Hello friends, welcome to SSP Math. Today we are going to start new topic, that is linear operator. Linear operator is also called as linear map or linear transformation. Okay, so how to define this linear transformation or linear map? Definition is a map T from V to W. Map T from V to W between the vector space is linear if means when this map T is linear if T satisfies these two conditions, that is T of u plus v is equal to T of u plus T of v for all u v belongs to v, and second condition is T of alpha u is equal to alpha into T of u where u belongs to v and alpha belongs to r. Or we can check only one condition here, that is T of alpha u plus beta v is equal to alpha into T of u plus beta into T of v where alpha beta belongs to R and u v be the elements of V. If this condition is satisfied, then we can say that T is a linear map or T is a linear transformation. Now we will take one problem on this. So problem is define T from R4 to R3 by T of u is equal to x1 minus x3, x1 plus x2, x3 minus x2, x1 minus 2x2. Then we have to find here T of 1 minus 2 3, and second one is find x such that T of x equal to 8 9 minus 5 0. So we will start solution here. Now in problem given that T defined from R4 to R3. So first write given here T from R4 to R3 defined by T of u equal to x1 minus x3, then x1 plus x2, x3 minus x2 and x1 minus 2x2. So we have to find T of 1 minus 2 3. So T of u is equal to, means you have to take here u is equal to 1 minus 2 3. So T of 1 minus 2 3 means take T of x1 x2 x3. Okay, so x1 is 1, x2 is minus 2, x3 is 3. If we put here, then we get x1 minus x3 1 minus 3 minus 2, then x1 plus x2 1 minus 2 minus 1, x3 minus x2 3 minus 1, x3 minus x2 3 minus minus plus 2 5, and x1 minus 2x2, so 1 minus minus plus 2 into 2 4, that is 5. So this is the value of T of 1 minus 2 3. So second one is we have to find x such that T of x equal to 8 9 minus 5 0. So we have to find here x. Now when if T of x is equal to, in problem T of x given a 8 9 minus 5 0. So, but what is T of x? T of x is defined as x1 minus x3, x1 plus x2, x3 minus x2 and x1 minus 2x2. So we have to find x, means simply we have to find the values of x1, x2 and x3. Okay, so by equality of matrices, if we equate this with this, then we get first equation here x1 minus x3 is equal to 8. Second equation is x1 plus x2 is equal to 9. Third equation is x3 minus x2 is equal to minus 5. And fourth equation is x1 minus 2x2 equal to 0. Now this is the non-homogeneous system. How we find x1, x2, x3 here? So you have to write this system in matrix form. Take matrix AB and then reduce to canonical form. So what is the matrix form of this? 1 0 minus 1. Second row is 1 1 0. Third row is 0 minus 1 1. Okay, fourth row is 1 minus 2 0 into x1 x2 x3 equal to 8 9 minus 5 0. So this is Ax is equal to B. Now we have to take augmented matrix AB here and reduce that matrix to canonical form. Try to find x1 x2 x3. So if we consider augmented matrix AB is equal to here 1 0 minus 1 8, then 1 1 0 9 0 minus 1 1 minus 5 1 minus 2 0 0. Okay, now we have to reduce this matrix to canonical form using only elementary row operations. So we want here 0, here 0. So use operation R2 minus R1, R4 minus R1, keep R3 as it is. If you use this operation, then we will get the matrix 1 0 minus 1 8. Then R2 minus R1 means 1 minus 1 0 here, 1 minus 0 is 1, 0 minus minus plus 1, then 9 minus 8 is 1, R3 as it is, and R4 is 0 minus 2 1 minus 8. Now second diagonal element is this. We have to make this minus 1 0 and minus 2 0. So how to make that 0? For that we have to use operation R3 plus R2 and R4 plus 2 times R2. So if we use this operation, then first two rows as it is, that is 1 0 minus 1 8 0 1 1 1. Third row becomes 0 0 minus 1 plus 1. Minus 1 plus 1 is 0, 1 plus 1 is 2 here, and minus 5 plus 1 is minus 4. Then 0 minus 2 plus 2 0, 1 plus 2 is 3, and here minus 8 plus 2, minus 8 plus 2 is minus 6. Okay, and then third diagonal element is this. We have to make below this 0, means we have to make this 3 equal to 0. For that we want here 1. So use operation here R3 minus R4, because if you use 2 minus 3, then we get minus 1. So if you use R3 minus R4 here, then we get this matrix, because R1 and R2 are as it is. We have to change only R3 here. 2 minus 3 is minus 1, and minus 4 minus minus plus 6 is 2, remaining rows as it is. Now we want here 0. So last operation we have to use here R4 plus 3 times R2. So if you use R4 plus 3 times R2, then we will get here 0, or we will write one more step here, keep this 3 as it is. R4 plus 3 times R2, if we use this operation, then we get the last row of this matrix equal to 0, because 3 minus 3 is 0, and minus 6 plus 3 into 2 is 6 0. So we get this matrix. Okay, now using this matrix we have to find x1 x2 x3. So here rank of A equal to rank of AB equal to number of unknowns are 3. So system is consistent and has unique solution. So from first row we can write first equation x1 minus x3 equal to 8. From second row we can write x2 plus x3 is equal to 1, and from third row we can write minus x3 equal to 2. So by back substitution using this we get x3 is equal to minus 2. Okay, x3 equal to minus 2 if you put here, then we will get x2 is equal to 1 plus 2 हो जाएगा, minus 2 इधर लिया तो. So x2 is equal to 3. So x2 equal to 3 if you put here, or we put x3 equal to minus 2 here, then we get x1 plus 2 is equal to 8, minus minus plus. So x1 is equal to 8 minus 2, that is 6. So x1 equal to 6, x2 equal to 3, and x3 equal to minus 2, and therefore x is equal to x1, x2, x3, that is 6, then 3 minus 2. Okay, so this is the value of x. Similarly you take one homework problem is same. You try this problem. Define t from R4 to R3 by t of u is equal to 2x1 plus x3 plus x4, x1 minus 2x2 minus x3, and x2 minus x3 plus x4. Find t of 2 1 minus 1 3. Then second one is find x such that t of x equal to 3 minus 1 minus 3. So problem is same. You try this. Okay. Then next problem is show that the mapping t from R3 to R2 define as t of a1 a2 a3 is equal to a1 minus a2 a1 minus a3 is a linear transformation from R3 to R2, or maybe is a linear mapping from R3 to R2. Both are same. So you have to check this t is a linear mapping from R3 to R2 or not. So when we say that t is a linear mapping from R3 to R2, is if we take suppose here u is equal to a1 a2 a3, and V is equal to B1, B2, B3 belongs to V, okay, and alpha and beta be the elements of R, then we have to check T of alpha u plus beta V. T of alpha u plus beta V. If we get T of alpha u plus beta V is equal to alpha into T of u plus beta into T of V, then we can say that T is a linear mapping or T is a linear transformation from R3 to R2. So T of alpha u plus beta V, how we write here, is equal to T of alpha into u. U is here A1, A2, A3 plus beta into V. V is B1, B2, B3. Okay. Now multiply alpha and beta inside and take addition, then we will get alpha A1 plus beta B1 here, then alpha A2 plus beta B2 and alpha A3 plus beta B3. Okay, that is T of A1, A2, A3. What is T of A1, A2, A3 is defined in problem. T of A1, A2, A3 is defined as A1 minus A2 and A1 minus A3, means first and second key subtraction and first and last key subtraction. So here how we write this, this is equal to first and second key subtraction, that is alpha A1 plus beta B1 minus alpha A2 minus beta B2, means A1 minus A2, then A1 minus A3. So A1, that is first alpha A1 plus beta B1 minus A3 means minus alpha A3 minus beta B3. Okay, and we have to write this is equal to alpha into T of u. Alpha into T of u आना चाहिए. So is equal to, write down all terms of alpha and beta, or take from these four terms, take alpha and beta common. So if we take alpha common, alpha in bracket A1 minus A2 plus beta in bracket B1 minus B2 here. Okay, and same here, if we take alpha common, then we get A1 minus A3 and plus beta, if we take common, then we will get here B1 minus B3. Okay, and what we want alpha into T of u, and T of u क्या आना चाहिए, A1 minus A2, A1 minus A3 this way. So हम कैसे लिख सकते हैं इसको, we can write this as a order pair alpha into A1 minus A2, alpha into A1 minus A2, comma beta into B1 minus B2 plus, sorry, how we write this, this is equal to, we want alpha, so in first order pair if you write here alpha into A1 minus A2 comma second से यहाँ पर लिखना है हमें alpha into A1 minus A3 and plus same beta right here, beta into B1 minus B2 comma beta into B1 minus B3. Okay, now देखो इसकी यदि एडिशन ली तो फर्स्ट प्लस दिस वी गेट दिस एंड दिस प्लस दिस वी गेट दिस. ओके, ये चेंज नहीं होगा. देखो अब फ्रॉम दिस वी कैन टेक अल्फा कॉमन, सो इफ यू टेक अल्फा कॉमन ब्रैकेट में क्या रहेगा, A1 माइनस A2, A1 माइनस A3. ओके, एंड प्लस इफ यू टेक हियर बीटा कॉमन ब्रैकेट में क्या रहेगा, B1 minus B2, B1 minus B3. What is this A1 minus A2, A1 minus A3? This is T of A1, A2, A3. That is defined in problem. T of A1, A2, A3 equal to A1 minus A2, A1 minus A3 plus beta into, what is this, B1 minus B2, B1 minus B3. This is beta of B1, B2, B3. Okay, beta of B1, B2, B3. And what is this A1, A2, A3? A1, A2, A3 हमने assume किया था U, B1, B2, B3 assume किया था V. So this is equal to alpha into T of u plus beta into T of v. So this shows that alpha of T of u plus T of alpha u plus beta v is equal to alpha of T of u plus beta of T of v, and therefore T is linear transformation or linear map from R3 to R2. Okay, so same next problem है, you try this. Problem is same. Show that the mapping T from R2 to R3 defined as T of AB equal to A plus B, A minus B, B is a linear transformation from R2 to R3 or is a linear mapping from R2 to R3. Okay, so in this way the part of vector space is over here. In next video we will start inner product space. Thank you.